let x be distributed normally with mean mu and variance sigma squared, show that x minus mu and mu minus x have the same distribution. So there's two ways we can go about doing this. Now the first is by equating the CDFs. So essentially then, we're saying that the probability of x minus mu being less than or equal to some constant q is equal to the probability of mu minus x being less than or equal to that same constant q. So this is something that we have to prove. So let's start off with the right-hand side. Now I'm going to multiply both sides of the inequality with -1. And that reverses the direction of the inequality. So when I simplify that, I get the probability, or distributing this negative, I get x minus mu is greater than or equal to -q. Okay, now since x minus mu is still going to have a normal distribution, since x has a normal distribution and I'm just shifting that normal distribution by the constant of mu, then basically I'm saying that x minus mu is distributed normally with mean 0 and variance sigma squared. Okay, so that then means that this distribution looks something like this, with the mean being at 0. So if I draw in this region with -q somewhere over here, and then q would be somewhere over there and equidistant from the mean of 0, but on the other side of the distribution, then this probability of x minus mu being greater than or equal to -q corresponds with this region in the normal distribution. And that we know is the exact same as the area that corresponds to this region. Okay, so what that helps us with is realizing then from here that this equals to the probability that x minus mu is less than or equal to q, which is the exact same as the left-hand side over here. And so we have proven that the two distributions of x minus mu and mu minus x are equal. Now, the other way, which perhaps is more simple and uses something that uses a fact that we've used in this proof, is to just find the distribution of x minus mu and mu minus x. So we know this distribution of x minus mu is normally distributed mean 0 variance sigma squared. Now, mu minus x must also be distributed normally with mean 0 and variance sigma squared, and therefore we could conclude that x minus mu has the same distribution as mu minus x. And essentially this works because x being normally distributed, and in both of these cases, we're shifting x by a constant. So when we do so, what happens is the expectation of x minus mu equals the expectation of x minus the expectation of mu, which is a constant, which is just mu, which is equal to mu minus mu, which equals 0. And that's how we get that 0 in this distribution over here. And the same logic follows for mu minus x. We get mu minus the expectation of x now, which equals to mu minus mu, which also equals 0. So the expectations are equal. Then when we look at the variances, the variance of x minus mu equals the variance of x plus a constant, because the variance of a constant is 0. Constants don't vary. Okay, and the variance of x, we said, is sigma squared, and then the variance of mu minus x is equal to 0 plus -1 squared, because we take that negative out of the variance and we square it, times by the variance of x equals just the variance of x, which equals sigma squared. So in both cases, we'll have that x minus mu is distributed normally with mean 0 and variance sigma squared, and we'll also have mu minus x being distributed normally with mean 0 and variance sigma squared. So there's two ways, or there's a number of other ways that you could also go about proving this, but these are just two of the perhaps most obvious ways to prove that x minus mu is distributed in the same way as mu minus x when x is distributed normally with mean mu and variance sigma squared.